This paper introduces FanPad, a novel solution designed to facilitate dual-hand text input within head-mounted displays. FanPad accomplishes this by ingeniously mapping and curving the T26 QWERTY keyboard onto the touchpads of both controllers. The curved key layout of FanPad is derived from the natural movement of the thumb when interacting with the touchpad, resembling an arc with a thumb-length fixed radius. Inspired by the efficiency and familiarity of typing on a T26 QWERTY keyboard on a smartphone, we propose the SKPad layout. This layout optimizes the transition from mobile to touchpad typing, minimizing the learning curve and maintaining high input efficiency. But after some practice we find SKPad's drawback that having the thumb to move horizontally and vertically in relation to the touchpad can be unnatural because these motions engage multiple joints. Based on the SKPad, we further introduce FanPad. The more intuitive and effortless motion involves the fingertip sliding around the thumb joint, and the joint lies approximately along the line L, which is an abstraction of thumb's natural state. Thus, FanPad rotates and curves its keyboard rows to align with the natural movements of the thumb. The mathematical expressions for these arcs are displayed on the screen, where theta and r are the parameters determining the arcs. We propose a customized mechanism to find the best parameters for every user. Click the grip button, then slide the thumb casually on the touchpad. The FanPad will collect the trajectory data and estimate the parameters theta and r using least square method. We first only overlap the G, V, and space keys when splitting the T26 keyboard. But some users may attempt to reach the keys across the split line, for example, trying to type Y in the right with left thumb, causing poor performance. Therefore, we enlarge the overlap area to accommodate different typing habits. Finally, we get 4 layouts. Now we introduce the specific interaction methods and all functions of our keyboard. We use a word correction mechanism to improve performance. We use the head direction to select the words in the candidate bar. The selected one is highlighted and click the trigger to input it. Click the Shift or Sim key to switch to the corresponding capital letter or symbol and number. Then click again to switch back. Another way to input these characters are touching a key for a longer time. A selection box will pop up above it, including the uppercase letter, the corresponding number or symbol, and the lowercase letter from left to right. Then, slide and release the thumb to input the letter on the selected box, holding down the trigger, and then touching the left or right part of the touchpad moves the caret left or right. Releasing the trigger stops moving caret. We conducted the first user study to evaluate whether FanPad brings a better experience than SKPad. The performance of 2 overlap areas is also explored. In terms of entry speed, the ANOVA result shows a significant difference between FanPads and SKPads. FanPads significantly outperform SKPads, but no significant difference between the 2 overlap areas. In comparison to other methods, FanPad and FanPad-OV outperform HiPad and Flower, and is roughly equal to climbing. In terms of error rate, no significant difference is found between the 4 layouts. FanPads have relatively higher error rate. But no significant difference between the 2 overlap areas demonstrates the key's density is still in a reasonable range. In terms of workload and preference, all of 4 have low workload, but it reduces from SKPads to FanPads, while the preference scores goes higher from SKPads to FanPads. Note that though no significant difference observed, the performance of different overlap areas could vary between users. 2 of the 10 participants are 10% faster with FanPad than with FanPad-OV, and 1 is the opposite. Thus, as designed, the 2 overlap areas should be an option related to typing habits, rather than an optimization or degradation. We have 8 participants in the previous conducted an additional 6-day study to evaluate the performance improvement in the long term. The average typing speed rises 58.47 from 12.45 WPM to 19.73 WPM. The speed FanPads reaches is the best among HiPad, Flower, and climbing. However, the increase rate is relatively lower. It is probably because the fixed time of making sure that the thumb is at the right point becomes the bottleneck. In terms of error rate, no significant trend is observed along the 6 days. FanPads have higher error rate than HiPad and Flower, same as user study 1, but the gap is relatively small. Further optimizing word correction mechanism may reduce error rate. FanPad has demonstrated good performance. However, the densely arranged keys on the touchpads may reduce input accuracy. And it is only compatible with controllers with touchpads. In the future, we plan to enhance this method through 4 strategies: reducing key density, improving word correction and prediction algorithm, monitoring and visualizing thumbs in virtual environment, and get rid of dependence on touchpads.